Hello learners, welcome to today's lesson. This is Form 3 Mathematics under variation, but we are going to look at a subtopic called partial variation. But before we look at the question, if you have just come across this channel for the first time, kindly subscribe, hit the notification bell below so that anytime we produce a video like this, you will automatically be notified. Back to the question or the subtopic of the day under partial variation. When working under partial variation, a student is supposed to know that the variables are connected using an addition sign. Number 2 is that there are two constants under partial variation. And number 3, we form simultaneous equations which help us to find the two constants which we are going to use to write the equation connecting the variables before we tackle part B of the question. The question reads, quantity P partly varies as the square root of x and partly varies as x. Whenever you see the word partly used, you should automatically know that we are talking about partial variation. When x is equals to 3, P is 48, and when x is equals to 5, P is 110. Before we look at the question itself where we are supposed to determine the equation, we must first form this equation. Look for the values of the constants, then use those values to write the equation. We are told that quantity P, let us look at the solution for this question. Quantity P varies as the square of x, and partly, now in this case we are going to use an addition sign, and partly as x. From here we move down and say our P is going to be equal to, that means the variation sign is replaced by the equal sign. Then we introduce a constant here and another constant here. Now we can say our P is equals to k x squared plus mx. In this case we have introduced k and m as our constants. From there we substitute the values of x and p in this equation. We are told when x is 3, our p is 48. It means our p is going to be 48 when our x is 3. So if our x is 3 and here we have x squared, 3 squared is going to be 9. 9 times k, we get 9k, plus, of course, our x is 3. We multiply by m, we are going to have 3m. And when x is 5, we come to this question again here. X is 5 when p is equals to 112. So our p is 110, which is equivalent to k times x squared, and our x this time round is 5. So 5 squared is going to be 25. 25 times k, we get 25k, plus our x still remains 5. So 5 times m, we are going to have 5m. From there is nothing that prevents us from reorganizing the two equations such that we have our 9k plus 3m is going to give us 48, and 25k plus 5m is going to give us 110. Now what we are going to do once we form our two simultaneous equations, we are going to use elimination method to try and solve the values of k and m before we write the equation. connecting p and x. In this case, I want to eliminate either this part having k or the part having m. To eliminate, for example, in our case, this part which has m, we are going to use this 5 to multiply with the first equation. Then we use this 3 to multiply with the second equation. Then this 5 multiplies the entire of the first equation and 3 multiplies across. Now we take 5 times 9k, we are going to get 45k. Then we have 5 times 3m, we are going to have 15m, which is equivalent to 48 times 5, it is going to give us 240. From there again, we do it in the second equation by multiplying with 3 across, such that 3 times 25k will give us 75k, then plus 5m times 3 will give us 15m, which is equivalent to 110 times 3 will give us 330. From here, once we unify one part, we are supposed to subtract these two equations. When you subtract the two equations, this part which is equal will automatically cancel. Then we take 45 minus 75k, that will give us minus 30k, which is equivalent to, if you take 240 minus 330, this one is going to give us minus 90k. That one is going to give us, 240 minus 330 will give us negative 90. And if you want to get the value of k, we are going to divide both sides by negative 30 by negative 30. This one and this one goes, and our k here is going to be minus 90 divided by minus 30. The answer is going to be equal to 3. Then from there now, what we are going to do, we are going to substitute the value of k in either equation 1 or equation 2 for us to be able to get the value of m. We can say from, for example, equation 1, we know that equation 1 is here, 9k plus 3m will be able to give us 48. But already we know our k. So this is 9k, meaning 9 times k, and our k is 3. So if we take 3 times 9, we are going to have 27 plus 3m, and this one is going to give us 48. So if you want to get the value of m, we move 27 to the other side such that 3m will be able to give us 48 minus 27. And in this case, 3m is going to give us 21. And if you want to get the value of m, we divide both sides by 3 by 3. And in this case, 3 and 3 goes, so that we remain with m. And our m is going to be equal to 21 divided by 3, which will give us 7. In this case, we can therefore say our k is going to be 3 and our m is going to be 7. Once we have the values of the constants, we go and write the equation. Now we write the equation connecting the value of p and x. In this case, our equation is here, but the equation cannot be complete until we get the values of the constants. Now you go and say our p is going to be equal to k x squared, and already our k is 3, so it's going to be 3x squared plus mx, but our m is 7, so we are going to say this is 7x, and by so doing we have the first part of the question done. So this is the equation connecting p and x. Part B, we are supposed to find the value of p when x is equal to 6. So our B part of the question, P will be equal to 3 times X, and our X is 6, but that same X is squared, plus 7 times X, and our X is 6. From here, we are going to have 6 squared is 36. 36 times 3 will give us 108. This is 108 plus 7 times 6 will give us 42. And therefore, we can say our P is going to be equal to 150. And that gives us the answer to part B of the question.